buffer or suffer? In this example, I want to show you the impact of not having buffers when we have setups on some steps in the production or processing. So this is an example of a process producing orange juice. There are 3 steps: extraction, filtering, and bottling. They are highly automated and they just continuously produce at the following rates. Extraction can process maximum 80 barrels an hour, filtering 100, and bottling 120 barrels an hour. Everything would be smooth except that filtering requires a downtime of 30 minutes following every 4 hours of production, probably to clean filters or to do some additional maintenance. And of course, the important consideration here, there's no buffers between those steps. So what is the process capacity? So it would seem that the capacity, right, these are the rates that extraction can be done at 80 barrels an hour, bottling at 120 barrels an hour, which is not a problem. But it seems that filtering will not be done at 100 barrels an hour. It will be done at a slower rate, right? It could be done at what rate? We have to see the processing capacity here is calculated as, right, a batch size, kind of batch size would be, right, during 4 hours at 100 barrels an hour, we can produce 400 barrels. So the capacity of 2 would be 400 barrels over how much time? Over the total time of 4.5, right? 4.5 hours. This is barrels over 4.5 hours, right? Because it takes 4 hours and then we stop for 30 minutes while we do nothing. But so the total number of barrels will be 400 over 4.5 hours. So it would seem that this is simply 88.89 barrels per hour. And of course, this is a correct calculation. However, what we are missing from this, right? So let's continue this for a moment. So it seems that with this new adjusted capacity due to the setup, still extraction has the smallest capacity, and it would seem that extraction is the bottleneck now, and the processing flow rate, maximum flow rate or process capacity is this. However, this is an incorrect result because what we're missing here is that there are no buffers. When there are no buffers and the filtering is stopped, we cannot operate extraction either, right? So we will have to actually stop extraction too. And therefore, the extraction will not be able to process continuously juice at 80 barrels an hour. It will actually we'll have to do the same calculation as this one for extraction and also for bottling. Now, bottling, of course, is faster, but extraction, unfortunately, will be the slowest. The extraction will also have a reduced capacity, right? And this, by the same logic, and then it will be actually the processing of the whole process will be slower than 80 barrels an hour. So the capacity of this system is less than 80 barrels an hour. So to repeat again the point, the whole line must be stopped for 30 minutes, including the extraction. So when the system is operating, it is operating at 80 barrels an hour because the extraction is the bottleneck. But for 30 minutes, the system is stopped and everything, including the extraction, is not processing anything, right? So overall, the calculation that we have to do is the following. We have to see that when the system is operating for 4 hours, it is producing 4 times 80 barrels, which will be 320 barrels, right? And this is during 4 hours, and then there is additional 30 minutes, half an hour of setup. So it will be 320 barrels per 4.5 hours, which will give us 71.11 barrels per hour, right? So the actual process capacity works is actually less than 80 barrels an hour. It is 71.11 barrels per hour. And the reason for this is that this setup, even though it's required by filtering, is actually the setup for the whole process, for all steps, right? So where should we introduce a buffer in order to increase process capacity above 71 barrels an hour back to 80, hopefully, barrels per hour. So the answer to this is, of course, after extraction. Why? Because we want extraction to operate continuously, non-stop, while filtering and bottling it doesn't hurt to stop bottling, while filtering and bottling are stopped, right? We could introduce a buffer here, but it doesn't really make any difference because bottling anyway is a very fast step and it can catch up with a buildup of inventory here. So the answer here is after extraction, and this is the only step that is necessary. We can later see what would happen if we introduced additional buffer, let's say between filtering and bottling. So to summarize what we found out, adding a buffer after extraction to store output of extraction while the rest of the line is stopped for 30 minutes will eliminate the negative impact of downtime. Extraction can operate non-stop in this case at 80 barrels an hour, and the filtering plus bottling has a capacity of 400 barrels, 4 hours, producing at 100 barrels an hour. These two steps, right, they will produce 400 barrels in 4.5 hours, right? Because in 4 hours they'll be operating, and half an hour they'll be stopped for filter changes. So the production capacity of filtering and bottling will be 88.89. And this is still more than the capacity of extraction that operates non-stop. So the process capacity, which is minimum of those two sequential steps, will be 80 barrels an hour. The interesting question is also how much of a buffer do we need? So it's easy to see that the important thing is that if extraction is operating continuously, how much of the juice will it generate while filtering is down for 30 minutes? And obviously this is going to be, this can be like calculated from the Little's law, right? Inventory equals flow rate times flow time. This is a reversed order, right? So it's 80 barrels per hour operating rate here, flow rate, times the time of 30 minutes will create 40 barrels of inventory, right? So we need enough storage space for 40 barrels if we want to operate extraction continuously. And I want you to see also that it doesn't really matter if we want to introduce a buffer here. It doesn't make sense to introduce a buffer after filtering because there is not going to be any benefit in filtering and bottling when they are stopped. They can catch up, they can process the additional 30 minutes of extraction, right? About the 40 barrels they can process easily and catch up and empty this buffer before the next filtering, cleaning, right? Downtime is necessary. So there is no other buffer that is really useful in this example. And just to summarize, the conclusion in this example is that if you have flow interruptions, buffers can increase process capacity, or actually, in this example specifically, they can help you avoid losing process capacity on a bottleneck step, even if that bottleneck step is a different step than the one where you need the setup. Right? This is an example of what we call buffer or suffer situation. Either you introduce a buffer or your capacity will suffer.